Okay, I believe that this question right here stems from this one, which was posted earlier. Another tutor answered this question by setting up this integral, this definite integral, distributing the 4 minus x over this, or the square root of 4 minus x squared over 4 minus x, and then mentioning that one of those integrals was the area of a semicircle, and the other one was symmetric about the x-axis, and so the area is from -2 to 0 and from 0 to 2 canceled out and became 0. Okay, but now if you really want the antiderivative of this expression right here, even forgetting these limits for now, one way to do it is to use trigonometric substitution. When you see something like the square root of 4 minus x squared, the square root of 4 plus x squared, and you want to get rid of the radical, trigonometric substitution is the way to do it. Here's your right triangle. You want to set it up so that you're either using sine, secant, or tangent. And you want to set it up so that you can get x with equal a trigonometric expression without a radical in the expression. So here's how to do it. If we say one of the legs is x, the other is 2, the hypotenuse is 2, then this leg is the square root of 4 minus x squared. So the sine of theta is x over 2, x equals 2 sine theta, dx equals 2 cosine theta d theta. And here's the key. By setting up this substitution, we clear that expression of a radical. We get 2 cosine theta. And by the way, the 4 minus x is 4 minus 2 sine theta, because that's what x is. And we might have to use this later on. Theta equals the angle that has a sine of x over 2. So here's what it looks like after the substitution. This 4 minus x. Here's the square root of 4 minus x squared, and here's dx. And if you multiply these two factors together and then distribute, this is what you get. And we can break this apart into two indefinite integrals: 16 cosine squared theta, the antiderivative of cosine squared. You can look up that in a table of integrals. This one you can use u substitution, because we let u equals the cosine of theta. Here's what happens. Here's the antiderivative of cosine squared, where normal table of integrals will show sine of 2 theta, but it's probably easiest to break it apart using a trigonometric identity like that. If you distribute the 16, this is what you get. And for this antiderivative here, here's the work over here using u substitution. Now, where did I get all these values right here? That comes from the little right triangle. The sine of theta is x over 2. The cosine of theta is the square root of 4 minus x squared over 2. So now we're back to all x's, and now we can evaluate from -2 to 2 and multiply that all by 4 pi, which was the original question for the volume of that donut. Note that when you put 2 and -2 into these last two terms, they become 0, both of them. So it's really 4 pi times 8 inverse sine of 1 minus 4 pi times 8 times inverse sine of -1. Okay, and let me do a real quick paste here. I meant to do this earlier. we go. We'll go to board 3. Here's your original antiderivative. Here's, I'm sorry, your original integrand. Here's the antiderivative right here, which is what I had sorted on the previous board. Here's a slight change. And if I post this URL to Desmos and you go there, you'll see that this graph and this graph are identical, which kind of proves the point. Here's f of 2 minus f of negative 2. And if I multiply that by 4 pi, there's that 32 pi squared, which was given in the original answer. Okay, there you go. Hope that gave you some idea. Obviously, it's easier to do this problem using the technique mentioned in the previous answer. If you have any questions, post a comment.